Okay, so in this problem we have to find the velocity in the x and y directions or components in which where the position of the squirrels given. Okay, to find so the position will be, here, let me just rewrite this so it'll be easier to see. 0.036. My tablet is working pretty well now after fixing it. And the x component plus 0.0 cube t 3 and in the y component. So in order to find the velocity, the process that we do to find the velocity is to take the derivative. In other words, the derivative in terms of x of t will give us v of t. Okay, so the first one we'll just bring down, it will just give us the constant. Next we do 2 times 0.036, so 0.036 times 2. This will give us 0.072 meters per second cube t. Okay, so this is in the x component. And then let's find the y component. So it will be, all we have to do is the exponent, well, as a recall or a reminder if you forgot how to take the derivatives. So it'll be the exponent, you bring it down, so 3 times 0.019, it will give us 0.057 t squared. And this is in the y component. So now we have the velocity in both components or both directions. So this is number 1. Number 2, it says find the final position from the initial position. So we know that the change of velocity will give us the change of the change of position over the change of time will give us the change of velocity. So we can use this to formula to find the change of x, because the change of x is x final minus x initial, and we kind of know what x initial is. Well, when t is 0, meaning that x is 0, this means that, it's starting from the beginning, it's not really moving. But we want to find when t is at 5, which t will be the final t, and this is the initial t. And we want to find out what this is, right? So x minus x of y will give us the change of this, and this is coming from these two here. So let's do that. All we have to do is plug in 5 back to the original given function, in which the function itself is the position function. So why don't we do that? So times 5, so it'll be 1.4 plus 5 squared times 0.036, it'll be 0.9, and this will give me the I hat. So 5 cubed will give us 125 times 0.19. This will be 2.375 j hat. So when we plus that together, it should give us so this should be 2.3 I hat plus 2.375 j hat, and this is the this is actually the position vector. Okay. So in order to find we can find this is the vector, but we want to find the position. So what we really want is the magnitude of this because well, this is the vector of it, but we can also get the magnitude. So it would be 2.3 squared. That's how you find the magnitude. Another word, plus squared plus 2.375 squared. Okay, so this will give you the position. So we can do that to find the magnitude of this position vector, and this position vector is actually saying the position at that instantaneous time, which is 5 seconds, right? After 5 seconds, so it's from 0 to 5 seconds. Okay, so let's do number 3. It says at that time, what is the vector? So now we want to use what we got from number 1 to find the vector velocity. So in order at that t, so all we have to do is plug in t for that. So we can say the velocity vector will be 0.2a plus what's 0.72 times 5 will give me 36, and this is the I plus 0.057 times 25. This will just be 1.425 J. Okay, so we have to find what is the vector velocity. So we have if we want to find the vector velocity, it will actually be this. This is the vector, okay, of the velocity. This will be the magnitude of this vector, and we can also find it by using that approach that we did earlier, which is 2x plus y squared, and then you get that, and then to find the magnitude, this is to find magnitude. But let's say, what if we want to find the direction in which the squirrels go, the direction of the vector velocity of the squirrel? All we have to do is do tan, and then over y over x will give me the angle at which the direction of the velocity vector. And another way to look at this, or how do we know that we're using arctangent to find the direction? Well, when you add up the 0.2a plus 0.36 for the x component, we'll get something like this. So x and y So let's say that this is 2 and this is 4. And this is 1 and 2. Actually, I want to make this 2 and 4 so we can be consistent. So when you have that up, you actually have... Oh, I shouldn't have done that. I'm so silly. This is not a good choice, actually. So let's say that this is 0. This is 1, 2. There you go. That's good. Okay, so when you add the x component up for the velocity vector, you get 0.64i plus 1.425j. So we have here it's in the x direction, so it's coming here in the x direction, and then the I direction will be here. So the magnitude that we found here, when you actually proceed on, you actually get this. So this is the magnitude, okay? So this is the Vx and then Vy, and if we want to find the angle or the direction, all we have to do is find that. Oh. Here we go. Oh, okay, I'm trying to do yellow. Here we go. So right there. So we know SOHCAHTOA, so that's how we